Hi guys, so I'm going to be solving this problem, which is sine of x plus cos of x is equal to 1. It's a problem that can be solved in probably at least a good 5 or 6 different ways. So I'm not necessarily going to fit it in one particular type. As for the organization of the document, this one was fitted, I believe, into the identities or transforming type, which is the fourth one I'm doing in class, I believe. So I'm gonna therefore use kind of the factoring way, but there's many ways of solving this. So if I look at this problem, the first thing that comes to my mind is the fact that we do have an identity that's very similar to this. It says sine squared plus cos squared equals to 1. But because we don't have squares, it's kind of not working here. One thing you could do that I tried that does work is to square the side and then square this side. And then you're going to have the identity popping out of that. And then that's one way of doing it. The one I'm going to do here is by noticing that we have the same angle, but we have a sine and we have a cos. So it would probably be easier for us to solve this if we would have only sine or only cos. It happens that we do have identities to transform cos into sine or sine into cos. These are called, I believe, the co-function identities. And basically what I'm going to do is I'm going to change cosine for being a sine using this. I'm going to write it down. You should probably check on the sheet if you have that open in another tab. So this is a co-function. And let's use it. So I'm going to transform, like I said, my cos into a sine. And the identity says that cos of x is equal to sine of pi over 2 minus x. Which makes sense because if you recall from when we graphed the function sine and the function cosine were very similar, but one of them was shifted compared to the other, and it was shifted by pi over 2. So this is basically saying let's shift sine by pi over 2, and therefore we get cosine. So once we have this, now we do have two sines, but we have different angles. So if we have two sines that are added and different angles, then the one thing we can do is use the sum to product formulas. Sum to product. So I'm just going to invite you to go ahead again and check on your sheet for what that formula is. When we do sum two x's, it's going to become the following: 2 times sine of the sum of the angles, so x plus pi over 2 minus x. I'm going to write it down because it's a little hard to keep track. Minus x over 2, and then multiplied by cosine of the difference between the two angles. So if we do the difference, we're going to get x minus pi over 2 minus x divided by 2 is equal to 1. Simplify this. I'm going to divide the 2 on each, on the both sides, basically, just so that I have a 1/2 on one side, which is going to be pretty convenient. So here we're going to have sine of x minus x. These two cancel out. We're left with pi over 2 divided by 2, which is pi over 4. Sine of pi over 4 is a value that's known to us. We can just go in the circle and figure what that is. So, and then for the cosine, we're going to have x plus x, so 2x. 2x divided by 2 is just x. And then pi over 2 divided by 2 minus pi over 2 divided by 2 is going to be minus pi over 4. And that's equal to 1/2 now because I divided by 2. Sine of pi over 4. So, I mean, you can just go in your table if you have it. Otherwise, we know that pi over 4 is the 45-degree angle. So in the 45-degree angle, we know that it's root 2 over 2. So this is literally just root 2 over 2 cos of x minus pi over 4 is equal to 1/2. Now let's just divide by root 2 over 2, or this is the same as multiplying by 2 divided by root 2. Therefore, we get 1 over root 2, which is the same as root 2 over 2. It's nice because this is definitely one of our significant values. So what we're really doing right now is we're solving for cos of x minus pi over 4 is equal to root 2 over 2, which is just a basic equation now. So we can solve for this pretty easily. Again, I'm just going to draw a circle real quick, figure out what the values are. So oh, this is not good. Everything else was good, but not this line. And that's better. Okay, so root 2 over 2, this would be your second value. 1, 2, 3. So it's this point, this middle point, which is a 45-degree angle. So we need the 45, which is pi over 4. So the first angle is going to be x1 minus pi over 4 is equal to pi over 4 plus 2k pi, or 2 pi n. Doesn't matter if you use k or n. Therefore, x1 is going to be equal to pi over 4 plus pi over 4, which is pi over 2. Pi over 2 plus 2 pi n. No. Yes, 2 pi n. So that's our first value. And then we're going to have a second angle, which is going to be x2 minus pi over 4. And this angle that is down here is minus pi over 4. So I'm going to say minus pi over 4 plus 2 pi n. And the good part about keeping it as a negative angle is we have that these two just cancel out. So we get x2 is going to be equal to simply 2 pi n, and that's it.